So anyways, we're going to talk about the continuity function. And then we're done with the limit of x approaches infinity. Continuity functions. So when we're talking about the continuity function, we are saying a continuous function has no breaks, hole, or gaps. So myself, I'm going to go straight. How do we see that a function is continuous or continuity? So f at x is continuous at a point C if number one, if f at C is defined. Number two, if the limit of x approaches C, I don't know why at your side you're using C, but they normally use A here. It's just that yeah. Let's use what they use. You'll notice being updated in something else. All the boys been on, when you reach mainstream, you will see they will use A. The function f at x is continuous at a point A if our x approaching A of f at x is defined or exist. If our f at A is defined, and when our f at A x approaching A is exist. Number three, when the limit of x approaching A of f at x is equals to f at A. Our good. So guys, do you understand? Hello? Guys, can you hear me? Okay, you will respond when you hear me. I'll be waiting for you.
Yes.
So now, NB. NB a function, or let's say a function f is continuous if and only if the limit of x approaching a from the left of f at x is equals to L, which is nothing but equals to the limit of x approaching a from the right of f at x. In other words, the function is continuous if the left-hand side limit is nothing but equals to the right-hand side limit. Are we still together? Hello?
Yes.
Okay, so now let's take an example and see if we will remunerate Let's take an example. Number one, they said find x so that the function f is defined, so that the function f defined by here your slide examples are not making sure, like they're not written in the way that the question must be written on, but anyway, we'll just try to correct it. So we've got f, we are given f at x is equals to 2x minus 1. This one, it only works if x is less than 2. And less than in limit, it means from left, x, if x is greater or equals to 2. I will find.
Yes.
So now, I'm going to solve this one straight forward so that everyone may understand. We are going to say, since this one is from left, we are going to apply the limit of x approaching 2 from the left-hand side of a function f at x, which is nothing but going to be equal to the limit of x approaching 2 from the left of a function 2x minus 1. So now our limit can approach 2. It means we are going to put 2 there, and we state minus 1, and this is nothing but going to be equal to what? Hello?
3.
It's going to be equal to 3. And again, here it's up to you. It's whether you apply the limit of x approaching 2 from the right. But since there is an equal sign here, there's no use for you to go and apply that one. You can say f at 2. This is equals to, and then we've got equals to. When x is equals to 2, our function is equals to this. So it means where there's the x, we're going to apply, this is 3 over 2 into 2, then we get 3. So from continuity, we know that f at a is nothing but what? Hello? From continuity, we know that the limit of x approaching 2 from the left of f at x is equals to f at 2. Therefore, it means f is continuous at x is equals to 2 because we get the same solution. Remember, we used this one. Are we good? Hello?
Can you please repeat the example?
Since here, in fact, here, let's say we're proving that the function is continuous. Let's remove this line software. Let's say the function f is continuous. So how do we prove that? We must first find the left-hand side limit or the right-hand side limit or f at that limit. So here, if here there was x is greater than 2, we were not going to apply this. Are we good?
Yes.
We are going to apply the limit of x approaching 2 from the right of that f at x. But because there is equal sign, there is no use for us to go there. We're good now.
Yes.
So since the first solution is equal to the second solution, therefore it means our f is continuous at x equals to 2. Because we know that from continuity, we have it. F limit of x approaching a of f at x, it can be equal to f at a. Are we satisfied?
Yes.
And we go to the next slide.
Yes.
Guys, are you there?
Yes.
So now let's go to the next question. The next question says what? Can we do the next example?
Yes.
Okay. I want you guys to try it first, and you will tell me why did you say that? You have an example with you, is that so? There we go. Can you see the example?
Yes.
Yeah, please try it. I'm giving you 4 minutes. I hope you are done, is that so? Hello? I said, first of all, we find the limit of x approaching this number. But since if you do your hand that do this sign is only left. So it's going to the left, which is minus 2 from the left of a function f at x. And that function f at x is this function. Are we good? It means this is nothing but equals to the limit of x approaching 2 from the left, and our function is k x squared minus 1. Then when they say x, we go and plug 2. It means we're going to have k into 2 to the power 2 minus 1, which is nothing but equals to 4k minus 1. Rotena.
A.
Okay. So now, tabubili, we're going to find the limit of x approaching 2 from the what? From the right-hand side. Then of which function? Of this function. So it means we're going to have the limit of x approaching 2 from the right of f at x, which is equals to the limit of x approaching 2 from the right. So what is our function? Our function is x minus 3. Then when they say x, we're going to put 2. This is 2 minus what? 3, which is nothing but equals to minus 1. So from continuity, what do we know from continuity? NB. The left-hand side is equals to the right-hand side. Is that so? The left-hand side limit is equals to the right-hand side, which means it means our limit of x approaching 2 from the left of f at x is equals to the limit of x approaching 2 from the right of f at x. Then it means we're going to substitute. What is the limit of x approaching 2 from the right? From the left, we got that is 4k minus 1. This is equals to this one. We got that is minus 1. Then we saw 4k. 4k, 1 when it goes to that side is going to be 0. Is that so? Hello?
Yes.
It's not going to be 0.
Going to be 0.
Therefore, our k is what? Is 0. Please go and correct your slide. Your slide, there's a mistake when they substitute here. Did you open your slide? Hello? Are on the way. En matamera.
Mvula.
Apa ka slide chabe way. Abango be -1. But that one is, which is totally wrong. So go and put this and that and correct the slide. Can we proceed?
Yes.
So can we proceed now to the next question? Did you see what I said, ne?
Nṋe ndi kha ḓi ṱoḓana nazwo zwithu zwi vhona.
Other than I mean a sliding.
Na hezwo zwine zwa khou ambiwa.
Ka page 16 ya slide. Osika, Oswana. So ka korrekululeyo aite usula. Can we proceed now?
Yes.
Questions are slightly shabby there, but we don't worry. Some of the big resource on my all right. So let's proceed. There we go. Let's say we've got this kind of equation now. You can see the screen, right?
Yes.
Okay. But why here they say discuss the continuity of a function f at x equals to 0 and x equals to 3? You can even discuss everything without even telling me that x is equals to what? So now, due to time, because we don't have time, let's do it together. They want at x equals to 0 and x equals to what? This is simple. And is equals to. So we can say f at 0. Why are we saying f at 0? Because it's included here. Here we can't say f at 0 because there's no equal sign. We're going to apply limit of x approaches 0 from the left. That's all. Sharply. Then f at 0 equals to 0 minus 1, which is equals to what? Minus 1. And f at 3, because it's equals to, is nothing but 12 minus 3 to the power 2. Then what do you get as a solution?
-7.
Minus 7. 12 minus 90. Okay.
Una 3.
Anyway, therefore, you are going to say what? F is not continuous, right? Since f at 0 is not equals to f at 3. Or you can prove it by what you think you know, by the limit, but it is not necessary this one if you have got the equal sign. Limit of x approaching 0 from the left. We are lying if we're saying that because even this one is from the left, but it gives you the same solution. Yeah, we're fine. From the left of a function x minus 1 is equals to 0 minus 1, which is equals to minus 1. And again, we've got the limit of x approaching 3 from the right of a function 12 minus x squared, which is nothing but 12 minus 3 to the power of 2, which is 3. Therefore, f is not continuous. Are we good? Hello? Since the left-hand side limit is not equals to the right-hand side limit. So now, can we do another example?
Yes.
Are you guys following?
Yes.
Asikundi nandi
Izokonda.
kuna zvinoni kufunzwa zvakadhikwamba ini yayo inongani mangara uri mangara ma korona zvino nofunzwa zvokukonda atoba honest iwo oti nguva yeburai ari budzane ngo ndingadhibharirwa nazvino
Hai, ndikofunzwa asikobhala mara tindiching'wana zita asikobhala.
ndaanongopractice nadhipo uko kumoya kuri nichimwara zvidhobhara inango chiridzisha muchidhonedzana. Try this one. Two minutes left to finish up this simple question. Then we'll do solution.
Yeah. Yes.
We're going to find the what? The limit of x approaching what? 2 from the left of our function f at x. Then we're going to substitute. This is the limit of x approaching 2 from the left. Our function is minus x squared plus 1. Then when we substitute, this is minus into 2 to the power of 2 plus 1. Then we get minus 3. And again, we find the limit of x approaching 2 from the right of our f at x, which is nothing but equals to, we substitute our function. The one that is from the left, from the right is this one, which is this function. So it's x plus k. So here there was not supposed to be k. Anyways, let's proceed. This is 2 plus k. Then from continuity, we know that the left-hand side limit is nothing but equals to the right-hand side limit. which means that minus 3 is equals to 2 plus k. Yes, Madamela?
Is it like important or from continuity?
Hey, anoda kuzviringanyisa zvikubva gai?
Okay.
Madamela? Anoda kuzviringanyisa zvichibva gai?
I was just asking, or like, is it?
Oh, echichikuwo kubva chore saka ichiri continuity. Nṋe ndi ḓo ro tea zwikhuwa zwine zwa khou balelwa vho maḓuvha izwi.
ndo fhumula u sharp. Ndi khou ḓi ṅwalela mara ndi khou thomiwa u sharp.
Ndo ndi khou fhisa na ḓuvha ambudza.
Why nne not andan?
Nga andano ya tshikona tshikhuwa. Mba ndano bva nga ngeno.
Zwino nṋe be ndo to semela univen obvious ndi a tshi ḓivha tshikhuwa.
Hai, zwo balela tshikolo tsha Marude.
Marude ndi marude.
Hey, a re phanḓa. Hey, vha i vhoni. So, are you guys satisfied?
Yes.
So it means now I can give you a work to do about continuity. That can be your homework. I want to see how you think or how you present things. Are we fine?
Yes.
Or we can give you time to write and we do it together. Let me check my timetable. Yeah, we are left with the 10 minutes. We are fine. Let me just add time for you. Ndinasafuna chikoro vyeuvana tototangana vana vasafuna chikoro savivi. Foundation ndinotangana nekaministry most of the way ndinoitanga izvi. Angozo notosendereriwa. Yakone. Angozo notosendereriwa.
Chikolo chavava vatu. Riva rina pfupho.
Nawanda why nechipikone.
Ndipikone, not kone.
Kone kumuti, kone kumuti.
Already, artendo ndikone kumutu.
Hey, inakuwa ndina. So now, this is suppose that f at x is defined piecewise as. Now from the measurement, the next time down with the correction. So now, we know what to do. Is that so? Hey. We're going to find the limit. Is that so? Now, that's the equation 1 or 2. Appear to read. Reference of the corner or the babado. Approaching is approaching minus 2 from the left of FLX. Is that so? Hello. How are we? Tamara, chinofumura, ningokona view.
hayi ndo ndinamatamela na ndani na munyayi vachamba
awambeni.
okay yes
Yakona FGS and you can yes. Then plus 2a. Then we've got what? 4 plus 2a. Then we're going to get f at 3. Hey, no. F at minus 2. Because we can see that, yeah, indeed, is remunerating. Is that so? This equals to there. Because of that equals to, we can get f at minus 2 plus c. Then this is equals to minus 6a plus c. Are we fine?
yes
Then from continuity, we know that 4 plus 2a equals to minus 6a plus c. Is that so? So let's make c subject to the formula, or a, but let's make c. Remember the varnami. The other mona must one at it, 4 plus 6 is directly 8a as on it. Is equals to c. Therefore, Zambori c ashu eating anami. Now 8a plus 4. This one it. Yeah, by question 1 here should refer exam. Require kai pass. The limit of x approaching 1 from the right of a function f at x is equals to the limit of x approaching 1 from the right of 3x minus 2c. Then this is equals to 3 into 1 minus 2c. This is equals to 3 minus 2c. Are we fine?
yes
And here we've got what? F at 1. Then our f at 1 is equals to 3a into 1 plus c, which is equals to 3a plus c. So from continuity, we know that our 3 minus 2c is equals to 3a plus c. Then we do c substitute the formula. We're going to have what? 3 minus 3a is equals to what? 3c. Is that so? Let's take it as equation 2. And we substitute equation 1 on equation 2. Are we good? We're solving simultaneous now. And it means we're going to have what? 3 minus 3a is equals to 3 into, when there's a c, we'll put 8a plus 4. 8a plus 4. Are we satisfied? Hello? What did you
yes
Whenever we do the boom. But so as the university one is to the in China. For a Then we're going to have, we solve for a 24a plus 3a is equals to 3 minus 12. Then 24 plus this one is 27a is equals to 3 minus 12, you get what? Negative 9. Then you divide by 27, divide by 27. Then negative 9 divided by 27, you got what? You got your A
Negative
is
1
equals to
over
negative 1 over.
3.
Then to get C, we substitute A on that one. This is 8 into negative 1 over 3 plus 4. And your C is equals to what?
4 over 3.
4 over 3.
Yeah.
Then you are done. And this is the end of our lesson. Bye-bye. Thanks for the time. When are you going to write the test of